The sun, our nearest star. It gives us light. It gives us warmth. Life on Earth needs it. This star is our engine, powering our small world. Its energy is fundamental for all known life. We exist thanks to it. But this star has moods, a fiery, wild side. Sometimes the sun erupts with huge energy bursts. These are not just lights. They are powerful events sending radiation to Earth. Our star also has fury, a reminder of its power. These outbursts are solar flares and coronal mass ejections. They are natural events, part of the sun's cycle. Our modern world is different. We rely on technology. Delicate electronics are key. This makes us vulnerable now, a new kind of risk. Understanding the sun is vital, not just for its beauty, but for its potential peril. This knowledge empowers you. It is not to scare, it is to help you prepare. Awareness is our best defense against cosmic surprises. So let's learn more. What is a solar flare? Imagine a sudden flash, an intense burst of light on the sun's surface. That's a solar flare, a tremendous explosion. Not earthly fire, though. It's a magnetic energy release. Stored energy, let go. These flares happen near sunspots. Sunspots are cooler areas, darker patches on the sun, but they are magnetically active. The sun's magnetic fields twist. They get tangled up there like cosmic rubber bands. When they snap, a flare. Energy rushes outwards. The energy in one flare, it can be truly immense. Billions of atomic bombs, hard to grasp such power. This energy heats solar gas to millions of degrees. It shoots particles fast. Near light speed, they fly, called solar energetic particles. This is space weather. Flares often come with CMEs, coronal mass ejections. A CME is a giant cloud, plasma, superheated gas, billions of tons of it hurled out into space. Speeds are incredible. A flare is the flash. A CME is the cannonball. Earth can be in its path. Let's look at the sun's core. Not its physical core, really, but its magnetic nature. The sun is not solid. It's a giant ball of plasma. Superheated charged gas. This plasma always moves, churning like boiling water. This motion makes magnetic fields more complex than Earth's. The sun spins differently. Its equator is faster than its poles. This is differential rotation. It stretches magnetic fields, twists them around the sun like threads being wound, tighter and more tangled, especially near sunspots, storing vast magnetic energy. This tangling creates stress, immense cosmic stress. Eventually, field lines break. They can't take the strain. They reconnect suddenly into a simpler shape. This is magnetic reconnection, the snap we mentioned. This releases stored energy, powering the solar flare. Sometimes it launches a CME. The sun has a cycle, an 11-year activity cycle. Sometimes it is quiet, few sunspots or flares. This is solar minimum. Other times very active. Many sunspots, frequent flares. This is solar maximum. We are near one now, so more flares are likely. So, the sun flares, or it launches a CME. What happens to Earth? Our planet has shields, a magnetic field, our magnetosphere, and our atmosphere. These protect us daily from the sun's constant wind and its occasional storms. Life has adapted to this. First, radiation arrives from the flare itself. X-rays, ultraviolet light, traveling at light speed, reaching Earth in minutes, just over 8 minutes. This radiation hits our upper air. The ionosphere gets charged, disrupting radio waves, especially shortwave radio, affecting sunlit side communications. Next come energetic particles if the flare produced them. SEPs, solar energetic particles. They take minutes to hours to travel from sun to Earth. They are a radiation risk. Astronauts face this danger. High-altitude flights too. Satellites can be damaged. Their electronics can fail. Solar panels degrade faster. Finally, the CME cloud if one heads our way. This plasma takes days, 1 to 4 usually. It slams our magnetosphere, a cosmic shockwave, compressing Earth's magnetic field. This can create strong currents in the ground, on power lines, and beautiful, bright auroras, a sign of a geomagnetic storm. All right, let's dive into Section 5, Technology on the Brink. Our modern life depends on electricity and data. Satellites guide our travel and GPS. We rely on them for TV, phone calls, and the internet. Power grids light up our cities and run industries. These systems are interconnected and vulnerable. They're vulnerable to severe space weather. A coronal mass ejection shakes our magnetic field. Transformers can overload, causing blackouts. Solar flares can cause satellite malfunctions. GPS disruptions affect farming, banking, and timing. The economic cost could be enormous. Disruptions impact businesses, supply chains, and hospitals. Remember the Carrington event in 1859? A similar storm today would be far worse. Section 6. Preparing for the unseen, stockpiling for solar storms. So, the sun can act up. Our tech is at risk. What can we do? As individuals, we prepare, like for other emergencies, hurricanes, earthquakes, floods. Think, what if power is out for a very long time, and phones don't work? Self-reliance is the goal. Be ready for anything. First, water. Clean water, 1 gallon per person per day. Try for a 2-week supply. Store-bought water is easy, or store tap water safely. Next, non-perishable food. Canned foods are good. Dried fruits, nuts, jerky, protein bars for energy, enough for 2 weeks too. Don't forget a can opener and food for your pets. Light sources are crucial. Flashlights, battery lanterns, and many extra batteries. Consider solar chargers, or hand crank chargers. For phones, small devices, a battery or crank radio. This is very important. For news and updates, keep a good first aid kit, and needed prescription drugs. At least a month's supply. Cash is also important. If power grids are down, ATMs will not work. Credit card readers too. Having some cash helps. For buying essentials, if stores can open. Keep vital papers safe. IDs, insurance, medical info, in a waterproof bag. Make a family plan. Know where to meet up. Section 7. Riding out the storm. Safety during a solar event. A big solar storm warning? What should you do then? During the event itself, stay informed. First off, listen to that emergency radio. For official updates, authorities will give guidance on the storm status and local instructions. Follow their advice closely. It's for your safety. Try to use less electricity. This helps the power grid, reduces the overall load. Turn off unnecessary things. Unplug appliances too, especially sensitive electronics. This might save them from damaging power surges. If you use a generator, use it very safely. Never ever run it indoors. Carbon monoxide is deadly. Protect your electronics more, if you can, that is. Unplugging is a good start. Some talk of Faraday cages, metal boxes that block fields. You can try to make one. Wrap devices in foil, then plastic, then more foil. Or use a metal garbage can, lined with cardboard first. Its effectiveness is debated, but it might offer help. Check on your neighbors, especially if they are elderly, or have medical needs, or live alone. Community support matters in any kind of crisis. Share information if you can. Share resources if possible. Stay calm. Panic is bad. A plan helps reduce fear. The storm itself won't hurt you. Infrastructure failure is the risk. Section 8. Beyond the blackout, long-term resilience and adaptation. A severe solar storm could mean a long recovery. Not just days without power. It could be weeks or even many months. If large transformers fail, they are hard to replace. Custom-built, long lead times. So think beyond just days. How would society cope? It would be a challenge. Communities would need to adapt. Local government would be strained. Emergency services overwhelmed. Neighborhood groups could help, sharing skills and knowledge, bartering for needed items. Local communication networks. Skills like first aid, basic repair skills, gardening for food, water purification methods. These become very valuable. Governments are working on this. And private industries too. To make infrastructure stronger, more resilient power grids, better shielding for satellites, improve space weather forecasts. This is a global problem. Space weather affects everyone. International teamwork is vital. We need more research, more monitoring of the sun, more investment in protection. For individuals, resilience means cultivating adaptability, learning new practical skills, reducing reliance on systems where that is possible, building strong social ties. The challenges would be great, but humans are resourceful. We have faced big crises, and we have adapted. The key is to prepare, not just wait and react. Section 9. Conclusion. Knowledge is power against the sun's fury. The sun, our star, magnificent and life-giving. It warms us with light. It drives Earth's rhythms, but it also holds immense, untamed power. Solar flares, CMEs, reminding us we live in a dynamic universe. Understanding solar events is about gaining knowledge. We cannot stop solar flares, but we can see the risks. We can make smart plans to lessen the impacts. Preparing for these breaks is common sense. Facing solar flares with knowledge strengthens our resilience, ensuring we can thrive on our beautiful planet, our home, orbiting a star.